Hello students. So far we discussed the concepts of trigonometric equations as well as trigonometric inequalities. Now I'll be taking up some questions which have already come in the exam in the past in JEE Mains, Advanced, IIT-JEE or many other exams. I'll be giving you some tips and tricks to solve those questions quickly, hence saving some time to invest in other questions. Let's start with the first part. Now we've already covered the concepts, the way we have seen various type of examples. Then we went through the type of questions that can be framed from trigonometric equations and their solutions. We had some discussion on trigonometric inequalities. Then now let's have some miscellaneous examples. So the first example that I have in front of me is sin 6x plus cos 6x is less than 7 by 16. Then tan square x, I have to find out the value of tan square x lying between. I have to find the range in which tan square x would lie corresponding to x, which has a condition of sin power 6x plus cos power 6x less than 7 by 16. So let's start with this. I can write this as a cube plus b cube, that is sin square x whole cube plus cos square x whole cube less than 7 by 16. Now a cube plus b cube can be written as a plus b, a square minus ab plus b square, that is sin square x plus cos square x into sin power 4x minus sin square x cos square x plus cos power 4x is less than 7 by 16. Then this would come out to be 1, the first factor would come out to be, this whole would be 1 as an identity, and the second part, the second bracket can be written as this is sin square of sin square and this is sin square of cos square. So I will write them as sin square x plus cos square x whole square minus 2 sin square x cos square x minus sin square x cos square x. I'll just explain how I got this. This part is here and all this has been just the replacement for sin power 4x plus cos power 4x. So I'll solve it further, simplify it. Then I would get this first bracket again would come out to be 1. I would get 1 minus 3 sin square x cos square x less than 7 by 16, or I can say 1 minus 7 by 16 is less than 3 sin square x cos square x. That would give me 9 by 16 less than 3 sin square x cos square x, or sin square x cos square x greater than 3 by 16. So this is what I am getting till now. I would convert this in sin 2x term, so that I multiply this on both sides by 4 to get sin square of 2x greater than 3:4. I'd proceed with the same equation on the next slide, that is sin square 2x greater than 3:4. So sin square 2x greater than 3 by 4, I can write sin 2x as 2 tan x over 1 plus tan square x, as it is a square, so I would square this whole and I would get 3:4. Then I would get next part 4 tan square x over 1 plus tan power 4x plus 2 tan square x, for which I have to find the value. I have to find the value of tan square x. I have to find the region at which it may lie. So now I'll proceed with this so that I'll get a quadratic equation. By solving this, I would get 16 tan square x greater than 3 plus 3 tan 4x plus 6 tan square x. Now this would cancel out, giving me a 10. And solved further, that would give me 10 power 4x, 3 tan power 4x minus tan square x plus 3 less than 0. This would be factorized to 3 tan power 4x minus tan square x minus tan square x plus 3 less than 0. So the equation in which I am going to factorize is 3 tan power 4x minus 9 tan square x minus tan square x plus 3 less than 0. Solving it further, I take 3 tan square x common, so I am left with tan square x minus 3 minus 1 common, tan square x minus 3, and I would be getting a factor 3 tan square x minus 1 or tan square x minus 3 less than 0. So the two values of tan square x that I would get are 1 and 1 by 3, 1 by 3 and 1 by 3. So, and this tan square has to be as this value has to be less than 0, this value has to be less than 0. So either if one is positive, the other one would be negative, or one is negative, then other one would be positive. So I'll take it from there itself. So I have two regions. So whether if it is greater than 0, that is if tan square x is greater than 3 and less than 1 by 3, in which case I would get greater than 3 and less than 1 by 3. So no solution. The second case would be if tan square x less than 3 and tan square x greater than 1 by 3. In that case, this being 0, this being 1 by 3, I would get a region of convergence or overlapping region. Solution possible, I would get tan square x lying between 1 by 3, tan square x and 3. Now let's have a look at the solutions, options that we had. So that's 1 by 2 and 2, 1 by 3 and 3, 1 by 4 and 4, and none of these. And we have to find out in which of these two, between these two would the value lie, so that we got 1 by 3 and 3. So option B is the correct option for our question. I'll mark it as 2. Now moving on to the next example. The next example we have is tan a minus b is 1, sec a plus b is 2 by root 3. We have to find the smallest value of a and b. So we'll have, if I write tan of a minus b, I have to find the smallest value of a and b. So I'll have it as tan of pi by 4 or tan of 5 pi by 4. In first circle, the value of tan a and b would be smallest. That's why I took it in the first circle itself. So there will be two values of a minus b. So I can write a minus b as pi by 4 or 5 pi by 4. Whereas if I check for sec of a plus b being 2 by root 3, I would get cos of a plus b as root 3 by 2, or a plus b as, this can be written as cos of pi by 6 or minus pi by 6 or 11 pi by 6. Minus pi by 6 would not be lying in the first circle, so I'll be having 11 pi by 6. So a plus b can be pi by 6 or 11 pi by 6. Now if I compare that, I have two values, one of a minus b and one of a plus b. So for both the angles being positive, that's the basic property. So a plus b would always be greater than a minus b, as they both are lying in the first circle. That's why this property is valid, and this property would again be valid then. So if I consider and select the values for which this equation would be valid, I will get a minus b as, when I write a minus b as pi by 4 then a plus b would be 11 pi by 6, and if I write for the second set, I would get a minus b as 5 pi by 4, and a plus b would be 11 pi by 6 again. So this value would be left out because it is smaller than both the values for a minus b. Solving these two, I would get a as 25 pi by 24 and b as 19 pi by 24, and in this case I would get a as 37 pi by 24, whereas b would give me 7 pi by 24. So these are the four smallest values for which this solution would be valid. Next is I'll have to find the general solution to this equation. If I have to find a general solution for these two, I'll move on to the next slide then. Tan of a minus b is equal to tan of pi by 4, that's the base angle lying from minus pi by 2 to pi by 2, so that we get a minus b as n pi plus pi by 4. For cos of a plus b is equal to root 3 by 2 was again equal to cos of pi by 3. We get cos of pi by 6, and hence the value of a plus b obtained from this were 2n pi plus minus pi by 6. I'll change the variable here from n to m just for differentiation. Next is, if I solve these two, adding these two would give me 2a, then a would give me 1 by 2 times, adding these two, that would be 2m plus n times pi plus pi by 4 plus minus pi by 6, and subtracting these two would give me b is equal to half of 2m minus n, that is the equation 2 being subtracted from equation 1, that is 2 minus 1, and that is 2 plus 1. So b would give me 2m minus n pi minus pi by 4 plus minus pi by 6. So these are the general values. So these are the general values of a and b. That would give me all the solutions pertaining to the values that would be valid in solving the two equations that we had in the beginning itself. So these two are the solution sets of the trigonometric equation that we had. Moving on to the next problem. The next problem is the number of solutions of the equation 1 plus mod cos x plus mod cos square x mod cos x whole square plus and so on up till infinity is equal to 4, lying in the interval 0 to 2 pi r. So let's proceed with this. I'll have 1 plus, so if I have 2 raised to, let's say I'll call that as the whole expression as p is equal to 4. So I'll say that p is equal to 2, which would mean 1 plus mod of cos x plus mod of cos x square plus up till infinity is equal to 2. And from this, as this is a GP extending up till infinity, and also it is diverging because the value would be as the power is increasing and the value is less than 1, so value less than 1 with an increasing power would be diminishing and diverging towards 0. So it's a diverging series, and I can have the solution of an infinite GP, the sum of an infinite GP as a over 1 minus r, where a is the first term and r is the common ratio. So here I have the first term as 1 over 1 minus, and the common ratio is mod of cos x. So I'll write it as mod of cos x, and equate it to 2, I would get 1 by 2 is equal to 1 minus mod of cos x, or mod of cos x would be equal to 1 by 2, which would give me cos x as plus minus 1 by 2. This is again of the form of cos square theta is equal to cos square alpha. So I can have the solution as n pi plus minus alpha. That would be, this can be written as plus minus cos of pi by 3. So I would have n pi plus minus pi by 3. Now the solution set has to lie between 0 and 2 pi. So values corresponding to this for different values of n lying between 0 and 2 pi would be, for n is equal to 0, I would have plus minus pi by 3, where minus would be negated afterwards as it is less than 0 and out of the reach. Then next I would have, for n is equal to 1, I would have pi plus pi by 3 would be 4 pi by 3, and for minus I would have pi minus pi by 3, that would be 2 pi by 3. For n is equal to 2, I would have 2 pi plus pi by 3, that would be 7 pi by 3, that would be more than 2 pi, hence rejected. For n is equal to 2 and value negative, so I would have 2 pi minus pi by 3. So 2 pi minus pi by 3 would be 6 minus, that would be 5 pi by 3. So minus is rejected and hence I get pi by 3, 4 pi by 3, 2 pi by 3, 5 pi by 3. So these are the values that lie between the region 0 and 2 pi and satisfy the equation that are given to me. This was the equation, the range was given to me, and the solution set is this. This being the general solution. So students, we dealt with the first part involving the competitive level questions. I'll be continuing with the competitive level questions in the next two parts also, so stay tuned.